A very good morning, students. Today, let us see uh, what is the isometric projection. So, before going that, you should know the details about the conversion of two-dimensional picture view to the three-dimensional pictorial view. So, two-dimensional pictures are known as the orthographic projections or orthographic views, and the three-dimensional views are so-called the isometric views or isometric projections. So when you go for orthographic projections, there we will have only two dimensions in a single view. That is, if you go for a front view, there will be a length and a height, only two dimensions. If you go for a top view, there will be length and breadth. And if you go for a side view, there will be breadth and the height as the two representations of their geometrical shapes. Coming to the point of a three-dimensional view, and any view, just you can see the length, the breadth, and height of a object. This is a part of the three-dimensional view. So here the conversion, this isometric projection is nothing but the conversion from 2D through 2D to two-dimensional view to three-dimensional view. So before going to that, we should know some of the important points about the three-dimensional view that you have to take it into the consideration, and how to start the three-dimensional pictorial view, and on which side you have to take the length, and on which side you have to take the depth or breadth of the object, and on which side you have to take the height of an object, and what should be the difference angle between these two uh, lines, and all these things. So now what to say is can know some of the points here. You can clearly see. So here you can some of the important points, that is one, isometric views, the lines and the planes. So here you can see the first one, the three lines AL, AD and AH. So where is AL, AD and AH? So here you can see this is AL, this one is a line, and AD is one of the line, and AH is another line. So these are the three lines, major lines, that implies the angle between these two, ADAL, angle DAL or angle LAD is equal to 120 degrees, and DAH is 120 degrees, and HAL or LAH is 120 degrees. So the three parts, one, this is 2, and this is 3, which is making an angle of 120 degrees with each other. So these three lines AL, AD and AH meeting at a point A are making 120 degrees angles with each other is termed as the isometric axis. So after that, the lines parallel to this axis. What is that? Suppose if AH is there, it is one of the axis. The lines parallel, what are the lines parallel to AH? So this is one line, this is another line, right? And what is the line parallel to AL? This is another line, and this is also another line which is parallel to AL. And if you come to the AD is an isometric axis. If you take isometric axis AD, and what are the lines parallel to that one? One is this one, and another one is this one. So these 1, 2, 3, 4, 5, 6, and all these lines are the isometric lines. So here, the planes representing the faces of the cube as well, the other planes parallel to these planes are known as isometric planes. So now you can take this one as one plane, this one as another plane, and this one as another plane. So these planes 1, 2 and these three planes are known as the isometric planes. So now in this one you have to make a note that isometric scale is there. So what is an isometric scale, and what is a things that you have to mention in the form of isometric projection? So that is when one holds the object in such a way that that all the three dimensions, that is length, breadth and height, are visible, then the proportion of all dimensions become proportionally inclined to the observer eyesight and hence appear apparent lengths. Okay, it is reduced. Then this reduction is nothing but 0.815. Suppose if 10 mm is the length of a object, then you have to multiply it by 0.85 so that you will get 8.15 mm. So that is equal to 9 by 11 approximately. It forms a reducing scale which is used to draw the isometric drawing and is called as isometric scale. So this is an while we're drawing isometric projection, it is necessary to convert the true lens into the isometric lens, right? So isometric projection is different and isometric lens measuring this one is different. So when views are drawn, then they can take directly whatever the dimensions which are given in the orthographic projection, you can take the same length and you can project there. And when isometric projection should be drawn, then you have to convert all the dimensions which is given in the problem is multiplied by 0.815, then you have to implement that. Then now how can you form, suppose if you are not having the calculator, and how you can convert this normal scale to the isometric scale, right? So next one, coming to see here, so this is the isometric drawing. The types of isometric drawing is divided mainly into two types. One is isometric view and another one is isometric projection. So in isometric view, whatever the dimensions which are given in the orthographic view with the true scale is taken into the consideration. Whatever the length is there in orthographic projection, directly we will implement in it one. Then coming to this next, in this height is there, the same height we will be taking, and whatever the depth or breadth is there, we will take it into them. Okay, and coming to the point of isometric projection, drawn by using isometric scale. So right, what is an isometric scale? Okay, so here you can see when you take this is AB as a line to form an isometric scale or isometric lens, there is a very simple system that we can do it. Draw a line AB and draw a line 45 degrees inclined to the AB line from point A, right? You draw a 45 degrees line here. So now AD is a line inclined to 45 degrees with AB. Okay, after drawing this one, make equal number of parts. So whatever it is, suppose if it is 1 centimeter, 0, 1, 2, 3, 4 like that. Otherwise, if you take 0 as a 1, 2, 3, 4, 5 like that. Then after drawing, you take 30 degrees from point A and draw another line. Okay, from point A, take 30 degrees and draw another line. After drawing this line, just simply from the parts which I have made in the 45 degrees line, that is 1, 2, 3, 4, just draw a perpendicular lines to the AB. So perpendicular lines to the AB. Then whatever the points which we get here, that is 0, 1, 2, 3 and this one is 4, these are the reduced lengths. These are the reduced lengths. Then we will call it as a isometric lens. When you see, if you naturally can calculate by whatever the length 1 into 0.815, that gives 8.15. Then if you measure this one also, you will get the same distance, right? So then you can see the pictorial views. Suppose the pictorial view of isometric view and isometric projection are one and the same, but as per the looking in nature, isometric projection is a little bit less than that of isometric view. Okay, then coming to the next point, isometric in for the plane figures. So you can see here what are the shapes are there, isometric shapes, front view and the shape of the top view, you will get it. Okay, it's a rectangle. So how you will get a rectangle, how to form a rectangle here. So here this is a length and this is the height of an object. Okay, then simply you can extend. This is AB. AB is the height of this object and AB is the height, and BC is the length, so that you will take the BC here, and AD is once again, sorry, CD is height, so CD height, and you draw a parallel line to these isometric lines. So now you may be about confused that what is the degrees between line, this is axis line and this BC line. So it should be 30 degrees, because in the previous case already we have seen this line, and that is ADL and LAH. The things that is the degrees between them are 120, and rest of here that is 30 and 30 beside, so that this line forms 180 degrees. Okay, so here you have to take 30 degrees from the axis line from BC. Then afterwards this should be height and this should be length. And another one comes a horizontal one. If you want to draw a horizontally, so it is a vertical rectangle. If you want to draw a rectangle horizontally, then this one will be AB, that is depth, and this one BC, and parallel lines like this. Okay, and coming to the another points, if you want to draw a triangle, okay, you want to draw a triangle, so you have to mention a rectangle in this one, and after that draw this 30 degrees line from any one of the point and the height from this point, and draw 1B and 2A first. After that 1B and 2A first, and after that you take the midpoint 3. This is 3 is the midpoint of BA, and you locate this 3 point here and draw a lines parallel. So this is how to draw a triangle in the vertical section. And if you go for a horizontal section, so this is how we have to construct a 1 2 BA like this, and point midpoint here and draw this line like this. This is a triangle, how to draw a triangle. And next, coming to the point pentagon, so for the pentagon also you draw a square here. Okay, so square here 1 2 3 4, and same like you draw a line here and you draw a 30 degrees line with the length L and height H, and draw this 1 2 3 4 at this particular point. And after that you locate these points 2B, and you can take from 2 point and you can make an arc here, and from 3 to C you can make an arc here. Okay, so that you will get all the points vertical pentagon. And if you go to this next case, this one, so horizontal pentagon, so first 1 2 3 4 will be drawn horizontally, and then next it is taken. So here you can identify if you want to draw a rectangle or a triangle or a pentagon in vertical, so height is to be taken into the consideration, length and height is to be taken into the consideration. If it is to be flat or parallel to the surface or a horizontal plane, then length and depth is to be taken into the consideration. So here there is a only change of consideration of length and height in the front view, and if we go for a top view, this is length and depth will be the constraint. Okay, so this is how to make the isometric view of a rectangle, triangle, and a pentagon normal view. And if you go for the circle, how to draw a isometric view of a circle. So now I'll take a line. So here I have taken a line here and draw the 30 degrees line this side and 30 degrees line this side. Okay, and you can draw the parallel lines for this one. This is one, and for this particular line I have drawn a parallel line to this here from this point, such that I formed a square in an isometric form, and put the midpoints on the 4 sides, and after that join all this from one corner and just opposite corners, and simply draw the line from the A to the major point and opposite point from this point to D and C, such that you will get the midpoints here. From these particular points you can draw the 2 points 1 and 2 from these particular points, so from 3 and 4. So 1 2 3 4, from these points taking as a center, you can draw 1 as a center, A as a radius, you can draw this one, and 2 as a center, D as a radius, you can draw here, and 4 as a center, this one, and 3 as a center, this one. So this is a way how to construct the isometric view of a circle, right? Thank you very much. We will see the other projections in the next video. Thank you very much.